This is the second part of solving quadratic equations by completing the square. And just a few quick reminders about what a quadratic equation is. So we're letting A, B, and C represent real numbers where A is not 0, so that we can have a term that is of degree 2. And remember, for a polynomial of degree 2, we always have two solutions. And we're going to be utilizing the square root property with our process of completing the square. So for this set of examples, we're going to have to look at step 1, where A is not equal to 1, and therefore we need to make it so. So our first example that we're going to tackle, the first thing that we're going to do is get our terms with our variable on one side and our constant on the other. So we have 2 times x squared plus 8x, and we need to add that 2. And so our variable terms are on the left, our constant term is on the right. Now notice that A is not equal to 1, and so we need to make sure it becomes 1. And so we're going to divide everything by 2. So we have 2 times x squared over 2 plus 8x over 2, and this is equal to 2 over 2. We need to keep this equation balanced and divide everything by 2. Now we're going to simplify this, and then our next step will be to complete the square. So I'm going to leave a space after my 4x right here. So 2 times x squared over 2 is our x squared, plus 8x over 2 is 4x, and we're going to complete the square, so we're going to leave some space there. And then this is equal to 1. So 4 drives this. So we need to identify B, which is 4, and then take half of it. And 1/2 of 4 is 2. And remember, this is the process of completing the square. So we're going to take that result and square it. And the result of 2 squared is 4. And so that fills in the piece in order to create a perfect square trinomial, which factors as x plus 2 times x plus 2. Because we added 4 to both sides, our constant is now 5. And 5 is going to be very helpful in terms of understanding what types of solutions we're going to have. So x plus 2 times x plus 2 is x plus 2 quantity squared. And now we're applying the square root property. We're going to take the square root of the left side. And because this is quadratic, we have two solutions. So positive and negative square root of 5. And notice 5 is positive, therefore our solutions will be real. But 5 is not a perfect square, so our solutions are real but irrational. And then finishing up here, the only thing I have left to do is get x alone by subtracting 2. So our two solutions come from x is equal to negative 2 plus the square root of 5, and then x is equal to negative 2 minus the square root of 5. Your first question is to solve by completing the square. 3 times x squared plus 12x minus 9 equals 0. And notice A is not equal to 1, so you need to ensure that it becomes equal to 1 and follow your steps. Our next example. Similar to your question, A is equal to 3. So the first thing I'm going to do here is get our variable terms on the left-hand side and our constant on the right. And then I am going to ensure that A becomes 1 by dividing all by 3. So we have 3 times x squared divided by 3 plus 5x divided by 3, and this is equal to 6 divided by 3. So in the next line, we're going to simplify all that we can, and we're also going to leave space so that we can complete the square. So 3 times x squared divided by 3 is our x squared. Notice now a is 1. Plus 5 is not divisible by 3, but I can bring 5/3 out as a distinct coefficient. We're going to leave some room here so we can complete our square. And then 6 is divisible by 3. That gives us 2. And now we're going to be immersed in the process of completing our square. So we need to identify b. b is equal to 5/3. And remember, we want to take this and be able to factor it into a quantity times itself, a quantity squared. So we need to take 5/3 and we need to split it into 2. So we need to take 1/2 of 5/3. And remember, with fractions, you simply multiply across, not cross multiply. That's different, isn't it? So this is 5/6. No, this will come back. But now we're going to take 5/6 and use this to create our perfect square trinomial. So we need to square 5/6. And 5/6 quantity squared is equal to 5 squared over 6 squared. So that is 25/36. So we're going to add that to both sides. We got to keep our equation balanced. Add it to both sides. And then, as I said, this is going to come back. This is the piece, isn't it, that fills in our 2 parentheses here. So we want factors of 25/36 that add to 5/3. So that is 5/6. So we now have our perfect square trinomial, which factors as x plus 5/6 quantity squared. And then on the right-hand side, notice we have an integer 2 plus a rational number 25/36. So we need a common denominator. And if we think about what 2 is 2/1. But I need a denominator of 36. So I'm going to multiply the denominator by 36. But I need to keep this balanced. I need to multiply the numerator by 36 as well. And so that gives us 72/36, which is indeed 2. So we have 72/36 plus 25/36. We now have a common denominator. And 72 plus 25 is 97. And 97 is actually very telling. Notice that 97 is positive, but 97 is not a perfect square. 36 is a perfect square, but 97 is not. So our next step, we're going to get rid of this square by taking the square root. So we have x plus 5/6. Remember, this is quadratic, so we have 2 solutions, which come from positive or negative square root of 97/36. And there's 2 things we can do. One, our job is to solve for x. So we need to get rid of this plus 56. An inverse operation of addition is subtraction. And then notice, we can apply our quotient rule for radicals. The square root of a fraction is equal to the square root of the numerator over the square root of the denominator, but the square root of 36 is 6. And notice very powerfully, we now have common denominators of 6. So we have negative 5 plus or minus the square root of 97 all over 6. And because 97 is positive but not a perfect square, that means our solutions are real. Real because 97 is positive, but irrational because 97 is not a perfect square. So our solutions are real but irrational. For our last example, notice our variable terms are on the left-hand side, but our constant is on the right. Notice also that a is not equal to 1. A is 2. Therefore, we're going to divide all by 2. So we have 2x squared divided by 2 plus 20x divided by 2 equals negative 70 divided by 2. So this simplifies to be x squared plus 10x, and I'm going to leave some space here, equals negative 35. So we're going to complete our square by identifying b, which is 10, taking 1/2 of it. 1/2 of 10 is 5. Remember that number, we're going to come back to it. 5 squared, because we're completing the square. 5 squared is 25, so we're going to add this to both sides. This creates our perfect square trinomial, which factors as x plus. And I want you to take a few moments and think about what goes in those parentheses. So what are factors of 25 that add to be 10? And remember, we're going to come back to that, aren't we? And so this is x plus 5 times x plus 5. Now this is a moment that I want you to recognize. Negative 35 has a larger absolute value than positive 25. So our outcome is negative 10. And this is the first time this has happened with us. Our outcome is negative, and I want you to think about what that's going to do for our solutions. So we have x plus 5 quantity squared equals negative 10. And applying the square root property, we have the square root of x plus 5 squared gives us x plus 5. And because this is quadratic, we have two solutions, positive or negative square root. Whoops. I don't know what happened there. Square root of negative 10. Solving for x, x is equal to negative 5 plus or minus the square root of negative 10. And because we have a negative underneath our square root, our solutions are imaginary. So we have two imaginary solutions. They are not real. And we could tell that way back here. And your question. So question number 2. Solve 4 times x squared plus 24x, and this is equal to negative 160.